Hi, this is Mr. Ward, and I'm going to do a short series of videos on how you can complete the square when there's going to be radicals involved. And I'm going to work through a few examples that are fairly straightforward, then I'm going to work through a couple examples where your lead coefficient might not be 1. So I'm going to start off with this one. And there's a few basic steps that you want to follow when completing the square. A first step is isolate the x squared and x terms by moving the constant term over to the other side using algebraic tools. A second thing that you'd probably want to do, well, we'll get to the next thing. So the first thing I'm going to do, so I put that there. My first thing is I want to get rid of this plus 3. What I mean by isolated, I want these all by themselves because it'll be a lot easier to figure out what the perfect square is. So copy pasta this. To do that, I'm going to subtract 3 from both sides because that will get rid of that plus 3. On the right side, I'll end up with negative 2. And on the left side, I'm going to end up with just the x squared plus 10x. Now, here's my next step that I need to take. Okay, this is step 1, of course. And then step 2, have the x coefficient and square it. Add that to both sides. Okay, so let's take a look at what is this x coefficient. The x coefficient is 10, so we're going to take half of that. Okay, so plus 10 over 2, and we're going to square that. We're going to add that, let me make that adding. Okay, we're going to add that to both sides of this equation. Okay. Now on the left side, I'm actually going to leave this. I'm not going to finish squaring it, but I will simplify it. So let's go ahead and clean that up. 10 over 2 is, of course, 5. And I'm going to leave that as 5 over there. Over here, on the other hand, I am going to have to finish that. So that's going to be 5 squared, which is 25. And I will simplify that by adding it all together. That's going to be negative 2 plus 25 will be 23. And now here's my next step that I'm going to take. My next step is I'm going to factor the left side into its perfect square form. Okay, let's do that. We're going to factor that into its perfect square form. So this is what I'm going to factor. Okay, so this here is going to become x plus 5 squared. Okay, and now I have just a couple more steps. So once I've done that, I've factored into its perfect square form. My fourth thing is to take the square root of both sides. Remember that the square root of a constant has a plus and minus version. So there will be 2 square roots on the right side. So we're going to get the square root of both sides. So I'm going to get the square root of x plus 5 squared, and that makes very interesting graphs over there, equals the square root of 23. And that's a plus version. There's a plus version and a minus version of that. Okay. Now, I'll deal with the plus and minus version in just a second. So that's going to give me on the left x plus 5 because the square and the square root cancel each other out. So just x plus 5. And then on the right, I'm going to have a positive square root of 23. And I'm not actually going to reduce that into some decimal form. This is the exact square root of 23. I'm also going to have an x plus 5 equals negative square root of 23. So don't panic when you see the square root of 23. you'll actually be able to leave it as the square root of 23. And if you actually needed to get an estimate of it, you can always use a calculator, square root of 23. And then you'd round it in a reasonable way. I'll just leave that there for right now. All right, we're going to have to go one more step, which is going to be to simplify both versions. So 5, simplify both versions and solve for x. Okay, so we're going to have two x values. So I'm going to subtract 5 from both sides. Now, subtract 5 here. And the convention is to put the minus 5 in front of the radical. This is the radical. Okay. And I'm going to have that version. And that'll just be x equals 5, negative 5 plus the square root of 23. And since there's a second version that was negative square root of 23, I don't need to actually recalculate it. It's just going to be that. So it's going to be x equals negative 5 plus the square root of 23, and x equals negative 5 minus the square root of 23. And those are the solutions. If you needed a rounded version, you could take this. But this and this are the exact answers. And the reason I say they're exact is because you could never finish writing the square root of 23 or negative 5 minus the square root of 23. It goes on forever. It has no end and no repeating pattern that stays consistent. It is an irrational number. So the completion of the square method is kind of useful for dealing with this sort of thing. And it's very convenient that we make a practice of not worrying so much about getting the decimal thing. Getting the decimal thing would be inaccurate. All right, so let's see if I'm going to encourage you to pause the video and see if you can try these next two. I'm going to try this next one here. X squared minus 12x minus 3 equals 5. I'm going to assume you paused the video and that you did the first step. If you remind yourself of the very first step, isolate the x squared and x terms by moving the constant term over to the other side. Now, you may be wondering, what do you mean by the constant term? I mean the one here that does not have any x attached to it. So I'm going to add 3 to both sides to get rid of minus 3. And I'll simplify that. That on the right becomes an 8, and on the left, I'm just left with my x squared and my x terms. Each one of these are called a term. And now I'm going to do my second step. Okay, my second step is have the x coefficient and square it. Add that to both sides. Okay, so let's do that. I'm going to add half of negative 12 over 2 squared. And then I'm going to do that to the same thing to the other side. And now we'll just clean that up. We'll simplify that. Negative 12 over 2 is negative 6. I'm going to leave that as negative 6 over here because it'll remind me of how that gets factored. Let me stretch this out a little bit. There we go, so we can see everything. I'll also blow this up a little bit too. Okay, so now on the right side, I do need to simplify that. Negative 6 squared is positive 36. And then I can put that together. That's going to be 44. 8 plus 36 will be 44. And then I'm going to go to my third step, factor the left side into its perfect square form. Okay, I've got it set up so it can be done that way. Okay, get to there. Here we are. So that's going to become x minus 6 squared, and that's going to equal 44. My fourth step is going to be to take the square root of both sides. Remember that the square root of a constant has a plus and minus version. Let's go back down there. So we get the square root of both sides. So the square root of x minus 6 squared equals the square root of 44. Now that's a plus and a minus, and there's a thing I'm going to recommend doing at this point. You might notice that 44 is 4 times 11, and we can actually we can actually pull this 4 out of the square root. The square root of 4 is 2 or negative 2, so I'm going to put that there. Okay. So let me just go back and show you what I just did. So that's 4 times this 11 inside the square root. I cannot reduce the square root of 11 without estimating, but I can reduce the square root of 4 into a 2 and a negative 2. Okay. Actually, let me do that in the next place. I'm going to just leave that there like this. And then I'm going to get the square root of the left side, which will just be x minus 6 because the square root and the square cancel out. And that's going to equal plus square root of 44, and it'll equal minus square root of 44. And once again, I am going to go ahead and take a factor of 4 out of there. And when I take a factor of 4 out of there, I get the square root of 4, which will be negative 2 or positive 2. And that's a simplified radical. Now I need to just solve this for x. So that's my last bit. So my last step, number 5, was to simplify both versions and solve for x. So I have simplified the radical, and just so you know how to simplify a radical, you're just looking for any factors of what's in the radical that are perfect squares. You can pull those out and get square roots of them. All right, so I'm going to add 6 to both sides, and so that'll be x equals 6 plus 2 square root of 11. You can call that 2 root 11, and it's also x equals 6 minus 2 root 11. Both of those are the solutions for that one. Okay, and you can see the rounded estimated decimal versions over here on the right. Okay, and this all came from these 2 versions. Okay, so let's go ahead and do one more, and then I'm going to stop the video, and I'll come back and do another video with more complicated lead coefficients. All right. So pause the video and see if you can figure out what you would do following the steps. Remember, the steps are up here. Isolate the x squared and x terms by moving the constant term over to the other side. Have the x coefficient and square it, and then add that to both sides. Factor the left side into its perfect square form. Take the square root of both sides. Remember that the square root of a constant has a plus and minus version, and then simplify both versions and solve for x. Okay, so see if you can do that with this one. X squared plus 7x minus 4 equals 11. I'm going to assume you did try that and you paused the video, and now you're back to see how I did it. So I'm going to go ahead and do this. So first thing I'm going to do, I'm going to isolate x squared plus 7x. So I'm going to add 4 to both sides. That's going to give me 15 over here, and over here, just x squared plus 7x. Now, I'm going to add half, the square of half of my x coefficient. So I'm going to say plus 7 over 2 squared, and I'm going to add that to both sides. And then we'll start simplifying. Now on the left side, 7 over 2, I could call that 3.5, or I could just leave it as 7.2, 7 over 2. I'm going to just leave it as 7 over 2. Over here, 7 over 2 squared is going to be 49 over 4. And this is one of those times I'm going to counsel that fractions will be your friend. And now I need to combine things over on the right. So 15 is the same as 60 over 4. So I can put that together. So that'll end up being 60 plus 49, which will be 109 over 4. Okay, I've simplified everything as far as I can do at this stage. I need to turn the left side into its factored form. Okay, so it's going to be x plus 7 over 2 squared. Okay, and now I'm going to go to my, I believe it was my fourth step. Yes, take the square root of both sides. So we'll take the square root of both sides. So that in there, and then let me cut that, put that in there. So I'm taking the square root of both sides, and I'm going to have a plus and minus version of this one over here. So on the left side, I'm going to no longer have a square. And on the right side, I'm going to have the square root of 109 over 4. Now, 109 I cannot reduce into a neat and tidy number. I'm just going to leave that in square root jail. So square root of 109. However, 4 I can get the square root of. So I'm going to call that 2 because the square root of 4 is 2. And now there's going to be a plus and a minus version of that. So this will be the minus version, and this will be the plus version. And my next step, my last step, is simplifying the radical and isolating or solving for x. So to solve for x, I'm going to subtract 7/2 from both sides. So x will equal negative 7 over 2 plus the square root of 109 over 2. And you notice we've got the same denominator. I'm going to deal with that in a second. And then I've also got the minus version. So those are my two solutions. I can simplify it just a little bit more. And here's how I'll do this. Since they have the same denominator, what I can do is I can just make it 7 minus here. And that's a negative 7 there. That negative could be in front of the whole fraction or not. The other version, we'll put the 7 here and it's plus. And put the negative there and get rid of that. So that is my answer. I've got negative 7 plus square root of 109 over 2 and negative 7 minus the square root of 109 over 2. And those are exact answers. You do not need to do anything with decimals. You are good at this point. All right, I think that's a good place to stop for this video. And then I'll come back and deal with the ones with